right, so section 5.5 starts on page 270. And again, what you're going to be going through today is adding, subtracting, multiplying, and dividing functions. Okay? Now, just a couple little rules or a couple little things, and it talks about the differences between them. The addition one, it says this: f plus g of x is the same as f of x plus g of x. Now, that's kind of the formal definition of it, but what they're going to refer to, or for this particular thing, is it's going to say something like this, where it's going to say let f of x equal 3 root x, and let g of x equal negative 10 root x. And if they're asking you to add f and g together, then you take the f function, so 3 root x, and add to it the g function, negative 10 root x. Now, quick question for you. Are the houses the same? Yeah. So what is 3 minus 10? Negative 7, the square root of x. And done. Okay? That's adding. You just combine like terms. So if you've ever combined like terms before, you have actually added functions together. It's the same thing. You're just combining like terms. So far, so good? Okay, now, here comes the second one. Subtraction. Again, the formal definition says f minus g equals f of x minus g of x. What do you think I'm going to do with these ones now? Yeah, subtract them. So I take 3 root x. I'm going to use the same f and the same g, okay? So f of x was 3 root x minus negative 10 root x. What do two negatives do? They make a positive. And it ends up being 3 plus 10 is 13 root x. And done. What do you think? Adding and subtracting, not too bad? Okay? Multiply. It's going to say f. Now this is important to watch what's going to happen here, because some of you guys have never seen this before. What does the dot mean? Multiply. Later on, you're going to see this. That's not multiply. Okay? When it's an open circle as compared to a closed circle. Closed circle means multiply. Open circle means something else. You're going to see that something else later. Like not today, though. Okay? So it would be the same as f of x times g of x. So if the f of x is 3 root x, and the g of x was negative 10 root x, how do you multiply those pieces together? Okay, straight across, you multiply the outsides together, then the insides together. What's 3 times negative 10? Negative 30. What is x times x on the inside? X squared. Now, careful. What is the square root of x squared? So I end up with negative 30x. What do you think? Not too bad? So we've added, we subtracted, we multiplied. What's the last one? This is even easier yet.
Is this all we're doing?
Yeah.
So like this is our last thing.
F of x over g of x. You split it into the top versus the bottom. So, what was the f of x function? 3 root x divided by, what's the g function? Negative 10 root x. Does anything cancel? If you've got something that matches on the top that matches with something that on the bottom, can't they just go away?
Yeah.
So for this particular thing, can't those just go away? So what do you have left with?
3 over
Negative 3/10. Nice. Okay. What do you guys think?
easy.
Good. Now, here's the one thing that I did not mention yet. Okay, it's not a ball dropper or whatever, like you guys always think I do. But for this particular thing, there is something else to the directions. That's the hard part. So if you thought that was hard or wasn't hard, awesome. The other part to this also comes with this part. It says, and their domains. Okay, so it'll also ask you for the domains. Now domains, all that means are the x values that can work. With this particular function, or those two functions that we had, f and g, right? It said the square root of x was in there, except for this final answer for this division one. When we got the square root of x, can you square root negatives? No. So for this particular thing, you would have to go when x is what to 0? Greater than. Because we want numbers that are higher than 0. So for all these ones that say find the addition between those two things, then we'd also have their domain is x is greater than or equal to 0. Now, how did I get 0? Because underneath the house, it was just x. So that's the number 0. If it would have said x plus 3 underneath the square root, then I would have put that equal to 0, and I would have had x is greater than or equal to negative 3, because negative 3 would have made that equal 0 when you add it. Okay? This one, same thing. X is greater than or equal to 0. Same thing. Same thing. Okay? That's how you figure out the domains. If you have square root. What if you don't have square root in place? Do you have any restrictions? Not necessarily. The only time you might have a domain restriction then would be if it had division of some sort. But realistically, a lot of times you don't. What do you think? This is it. There isn't anything else. I told you it was a short section. I'm just going to give you another one. Now, I want you to look at this particular problem. Is there a square root in play at all? No. Okay, I gave you one with the square root involved, but these are not square roots. These are polynomials. And what the question's going to ask you is it's going to say, find f minus g and state the domain. So what am I asking you to do? Subtract them. So take the first one minus the second one. So 3x to the third minus 2x squared plus 5 minus x to the third minus 3x squared plus 4x minus 2. Okay? Now the reason why I put it in parentheses like that is it's important because if you mess up the sign, guess what happens? Your whole problem's messed up. I don't want you to mess up. So I put them in parentheses just to show, so that way, especially when it's a subtraction between the two, make sure you're okay. Now all I'm going to do is combine like terms. What's 3x to the third minus 1x to the third? 2x to the third. What is negative 2x squared minus negative 3x squared? 1x squared. Because remember, two negatives there make that a positive. Then, if I look at the next one, I have a 5, but that's not the next one in the sequence, right? Don't we have 3, 2, usually 1, right? Is there an x somewhere?
Yeah.
Where?
4.
The 4? So is it 4x?
Yeah.
It's negative 4x because the sign goes through to each thing. If you want to distribute it out so that you don't forget, that might be a benefit to you. Then 5 minus negative 2. 7. Two negatives make it a positive. Be very, very careful. As Allie said over here, she said, if I mess up a sign, then my whole problem's shot. She's right. Okay, make sure you have your signs right. What do you think?
Easy.
Now it also asks you for the domain. Is there a domain restriction? Here's when you have domain restrictions. Is there a square root in play? Is there a square root at all?
Yeah.
Where?
Wait, no, never mind.
Not a square root, not a house.
Yeah, no.
Okay? So no restriction that way. Is there a fraction? No. So therefore the domain should be all real numbers. I can put anything in there. Okay? Now, here's the third part. It also says, then evaluate the difference when x equals negative 2. So you know what you have to do now? Put negative 2 in for x and let's see what we get. Okay? And that's all it is. I just put it in the answer. If you want to, Kylie, you can put it back up into here. But why? Why not just put it in this? Because you've already done that part. Okay? So then you would take 2 times negative 2 to the third plus negative 2 squared minus 4 times negative 2 plus 7. Negative 2 to the third is negative 8 times 2 is negative 16. Negative 2 squared is 4. Negative 4 times negative 2 is positive 8 plus 7. Negative 16 plus 4 is negative 12. Plus 8 is negative 4. Plus 7 is... You don't ever see that happen when you play?
Oh, really? I was confused what you were doing.
Okay, so there was my answer for subtracting the two. The domain, oops, I forgot to put that, all real numbers, which I put my fancy little r, because there was no restriction whatsoever. Everything should be fair game. And then 3 was also the answer because I put in negative 2, and what did I get? Now the only thing is it's not always going to be subtraction. They're going to ask you to multiply them, divide them, or add them. But then that's what you got to do. What do you think?
Easy.
Not all of them are going to have radicals. Some of them are and some of them won't, but realistically that's it. So if you turn to page 273. In looking at the directions, on 3 through 6, it says find f plus g and f minus g. So they have two answers for that part of it. And state the domain for each. Then evaluate both of them for the given value of x. So you got to throw in a number and see what you get after that. Then 7 through 12. Notice it says fg. What does it mean when it's just fg? Multiplication. Then f divided by g, state the domain, and evaluate it. Then on 13 through 16, it says, use a graphing calculator to evaluate f plus g, f minus g, f times g, and f divided by g when x equals 5. For that particular thing, what you do is you put the first equation in y1, the second equation in y2. That's what you do. Okay? Once you do that, or you could actually do or if you just add them or subtract them. So on like 13, for instance, if you take 4x to the 4th plus 24x to the 1/3 in your y1, and then you put when x equals 5, what does it equal? On your graphing calculators, do you remember where you found the 0, the minimum, the maximum, and the intersection feature? The very first option under there, so for the second trace, said value. That means if you want to put in a certain number to see what comes out. So what I'm going to suggest on that, just for like 13's purposes, for the f plus g, type 4x to the fourth plus 24x to the 1/3. That goes in your y1. Then once you get that in your y1, then you go second trace. And the very first option says value, which is going to ask you, what number do you want to put in for x? That's what it's going to tell you. When for 13, for instance, it wants you to put in 5. So then you put 5 in and hit enter, and it should pop out a number for the y. That answer, the y, is your solution. Okay? Just a different way of solving it. What do you think? So on page 273, we got 3 to 19 odd.